The paper discusses the industrial practices of requirements engineering, RE, for machine learning, ML, enabled systems in Brazil. It highlights that 41% of Brazilian companies use ML to some extent, with several challenges reported when engineering ML-enabled systems, including unrealistic customer expectations and vagueness in ML problem specifications. The study aims to investigate the application of RE in developing ML-enabled systems in Brazil, focusing on current practices, perceptions, and problems in the Brazilian industry. The findings indicate distinct aspects of re-implementation in ML projects in Brazil, such as RE-related tasks being predominantly conducted by data scientists, the most common techniques for eliciting requirements being interviews and workshop meetings, a prevalence of interactive notebooks in requirements documentation, and practitioners reporting problems including a poor understanding of the problem to solve in the business domain, low customer engagement, and difficulties managing stakeholders' expectations. The study emphasizes that RE can help address several challenges when engineering ML-enabled systems, but establishing effective RE practices in ML projects may be difficult due to the lack of practitioners engaged in formal RE activities and the absence of tailored techniques and tools for data-driven projects. The paper concludes that the results provide an understanding of RE-related practices in the Brazilian ML industry, helping to guide research and initiatives toward improving the maturity of RE for ML-enabled systems. This research paper explores the industrial practices of requirements engineering for machine learning, ML, enabled systems in Brazil. The study aims to identify the challenges faced by practitioners in this domain and inform the development of strategies to mitigate these difficulties. The survey design involved a literature review, expert feedback, and a pilot study to ensure the validity and reliability of the survey questions. The final survey consisted of 15 demographic questions and 17 substantive questions, focusing on the ML lifecycle, requirements, and deployment. The survey was distributed to professionals involved in building ML-enabled systems, and 276 responses were received, with 72 fully completed responses from professionals working in Brazil. The data analysis procedures involved using bootstrapping to calculate confidence intervals for the results. The survey questions were designed to be open text, allowing the challenges to emerge from the responses. The results revealed that ML practitioners are extremely worried about requirements, with the problem understanding and requirements stage being perceived as the most relevant and complex lifecycle stage. The study population consisted of 72 practitioners involved in data-driven projects across various industries in Brazil, with diverse backgrounds and professional experience. The majority of participants were employed by companies with over 2,000 employees, and the most common roles represented were data scientists, business analysts, and project leads, project managers. Regarding ML-enabled system experience, most participants reported having 1 to 2 years of working experience, with a balanced population of beginner and experienced professionals. The educational background of participants showed that 87.5% held a bachelor's degree, 45.83% held a master's degree, and 19.44% completed PhD programs in computer science, data science, or related fields. The study's findings highlight the importance of addressing requirements in ML-enabled systems, with data scientists, project leaders, business analysts, and developers being most associated with requirements. The results provide valuable insights into the current practices, perceptions, and challenges related to requirements engineering for ML-enabled systems in Brazil. The paper discusses industrial practices of requirements engineering for ML-enabled systems in Brazil. It presents findings on how practitioners typically elicit and document requirements, as well as the non-functional requirements they consider critical. In terms of elicitation techniques, interviews are the most commonly used method, followed by workshops, prototyping, and scenarios. For documentation, notebooks are the most frequently used format, followed by user stories and vision documents. Regarding non-functional requirements, data quality, model explainability, and model reliability are of significant concern. The most difficult activities when defining requirements include managing customer expectations, aligning requirements with data, and resolving conflicts. The study highlights the importance of considering these aspects in ML-enabled system projects. The research focuses on the practices of requirements engineering for ML-enabled systems in Brazil, specifically during the problem understanding and requirements stage. It incorporated axial coding procedures to provide an overview of the emerging codes related to categories such as input, method, organization, and tools. The study found that data scientists are taking the lead in addressing requirements, unlike conventional expectations. Practitioners reported difficulties in understanding the problem, managing expectations, and low customer or domain expert availability. The survey also revealed that traditional requirements elicitation techniques are still widely used, with computational notebooks being the most used tool for documenting requirements. However, a significant proportion of practitioners do not document requirements at all. The study identified threats to validity, including potential biases and limitations in the sample population, but ensured rigorous data collection and analysis procedures. The findings emphasize the importance of effective communication and technical expertise in bridging the gap between aspirations and technological feasibility. The paper discusses the industrial practices of requirements engineering for ML-enabled systems in Brazil. It presents a survey of 72 practitioners involved in the development of ML systems, focusing on their perceptions, challenges, and practices. The results highlight significant variations in RE practices compared to traditional systems, with comparable underlying problems. Key challenges include managing customer expectations, addressing ambiguities in requirement specifications, and ensuring data quality. The study emphasizes the importance of non-functional requirements, such as data quality, model reliability, and explainability. It also notes the need for better communication between project teams and customers, as well as the importance of stakeholder engagement. The findings suggest that while there are similarities with traditional RE challenges, ML-specific issues require tailored solutions. The study contributes to the understanding of current practices and challenges in RE for ML-enabled systems, highlighting areas for future research and improvement.